Hello everyone, welcome to the video where I'll be discussing how to combine uncertainties and percentage uncertainties. It's a very intricate topic and I see so many students struggling with this specific topic. I've also included a link in the description to a guide for mastering IL Physics Unit 6 where you'll get an in-depth analysis with examples from recent question papers. I'd highly recommend you to download it and go through it very thoroughly. So for this specific um, topic, we'll be taking Jan 2024 as our example. So the first question has nothing to do with combining uncertainties and percentage uncertainties, but since we'll be solving the entire question, I've just kept it. Just remember, when the question asks you to explain one technique, you either talk about what can you do to reduce the effects of random errors and what can you do to eliminate systematic errors. So you always repeat at different orientations and calculate a mean to reduce the effect of random error, and you check and correct for zero error to eliminate systematic error. Always remember, random errors cannot be eliminated. So for random errors, you use the term reduce the effect. And you cannot reduce the effect of systematic error. You eliminate the systematic error. This is where the main content of our topic begins. A student estimated that the thickness T of the center of the lens was approximately 5 mm. Explain the most appropriate instrument the student should use for a single measurement. Always remember, these are key words, everybody. Single measurement. Your answer should include a calculation. So when you look at this value, 5 millimeter, it's not a very large value. It's actually a very small value. So the instrument you use to measure such small values is a micrometer screw gauge. But you have to justify why would you be using a micrometer screw gauge, and you have to justify with a calculation. So when you are using a micrometer screw gauge, the resolution is 0.01. And with this resolution, the uncertainty is resolution divided by 2. That is 0.005 millimeter. And always remember, the equation for percentage uncertainty is uncertainty 0.005 divided by measured value, which is 5. Keeping in mind, the units are consistent. It's millimeter, the measured value, and the uncertainty is also in millimeter. So you're good. Times 100%. So 0.005 divided by 5 times 100 gives you 0.1%. So the percentage uncertainty is 0.1%, which is small. So using a micrometer screw gauge will give you a small percentage uncertainty, and that's why you would be using a micrometer screw gauge. So part B says the student placed a circular convex lens in a holder. She set up the apparatus. This is the apparatus. The student moved the position of the holder until the lens formed a sharp image of the wire mesh on the screen. She measured the distance u and v with a meter rule. The student determined the focal length f of the lens using the formula f equals uv divided by u plus v. Show that the uncertainty in f is about 0.2 centimeter. So it's one of the most complicated calculations you'll have ever seen in Unit 6. So be very careful. And I'd request you to take your calculator and do the calculation with me. Always remember, when quantities are in product form or division form, you always consider their percentage uncertainty, but when quantities are in addition form or subtraction form, you always consider the uncertainties, as in absolute uncertainties. So the first thing you have to do is find out the individual percentage uncertainties in U and V. So percentage uncertainty in U would be 0.1 divided by 29.6 into 100. It's 0.34%. Then you find out the percentage uncertainty in V the same way. That's 0.1 divided by the value is 19.2 into 100. That gives you 0.52. All right. Now, think of UV as a quantity. And since U and V are in product form, you consider their percentage uncertainties. So, percentage uncertainty in UV would be the addition of percentage uncertainty of U and percentage uncertainty of V. Because when quantities are in product, I repeat, I'll be saying this over and over again until it sits in your head permanently. When quantities are in product or division form, you always add up their percentage uncertainties. All right. So since these are in product form, you add up their percentage uncertainties. So 0.34 plus 0.52 gives you 0.86. 0.86%. Now, things are going to get a bit tricky. Look at this, U plus V. What do you do with U plus V? So the issue is when quantities are in addition or subtraction form, you always add up their uncertainties. So uncertainty in U plus V equals uncertainty of U plus uncertainty of V. That gets you zero point 0.1 plus 0.1, that is 0.2, right? Then you need to find out percentage uncertainty in U plus V. So equation remains the same, uncertainty 0.2 divided by the value of U plus V. So you add up U plus V, 29.6 plus 19.2. That's 48.4, sorry, 40.8 times 100. So this value is 0.2 by 48.8 times 100. This value is 0.41%. Right? Now, let's find out the percentage uncertainty in F. So when you look at the equation for F, UV and U plus V are in division form. And like I've been saying from the beginning, when quantities are in product or division form, you add up their percentage uncertainties. So percentage uncertainty in F would be percentage uncertainty of UV plus U plus V. So 0.86 plus 0.41. So 0.86 plus 0.41 gives you 1.27. 1.27%. You might be wondering, I'm done. No, you're not. Because the question did not ask you to find out percentage uncertainty. The question asked you to find out uncertainty. Now you recall the equation. Percentage uncertainty equals to uncertainty by value. So uncertainty in F equals percentage uncertainty times value. So I just found out the percentage uncertainty, which is 1.27% times the value of F is 11.6. So 11.6 times 1.27% gives you 0.147 something. So uncertainty rounded off in 2SF, uncertainty in F equals 0.15 centimeter. And since this was a show that value, always remember, you always have to give 1SF higher than the show that value. So the show that value here was in 1SF, so you have to give your answer in 2SF. The next part of the question asks you to calculate a value of n. So this is very straightforward. You just plug in the values into this equation. So n equals 1 plus the value of d is 5.02 whole square divided by 8 into, okay. So here's an issue. You look at all of the values. All of these are in centimeter. And you know when it comes to refractive index, n has no units, so the units must be cancelled out. So 5.02 is in centimeters, so centimeter squared divided by, in the denominator, the quantities must be in centimeter squared as well. But when you look at t, this is in millimeters, so this is what you have to convert. So 4.28 millimeter is divided by 10, 0 0.428, 0 0.428 times F is 11.6, which gives you, for this part is 0.63, and you have plus 1 here, that makes 1.63, and yes, the value has to be in 3SF, because all the other values in the data set are in 3SF. So D, T, and F are all in 3SF. That's why you have to give your N in 3SF as well. The next part asks you to determine the percentage uncertainty in N. So for this, let me bring the values from the previous part of the question. So let me bring the data for this. This is just for my convenience, so I can see what I have to deal with. Now they asked me to calculate the percentage uncertainty in N, right? All right. So what do we do? Since there is a plus sign here, right? You cannot just um, add this up. That's not how it works. If you look at these values, these are in product or division form. So when quantities are in product or division form, multiplication or division form, you deal with percentage uncertainties. By the way, this would be the lengthiest 2-mark question you'll have ever seen, and that's the only way to solve it. So you first start off with percentage uncertainty in d square, right? So percentage uncertainty in d square would be 0.02 divided by 5.02, 0.02 divided by 5.02 into 100, that's 0.39 something, 398. So you round it off to 0.40, but that is the percentage uncertainty in D. Percentage uncertainty in D square would be 2 times percentage uncertainty in D. That's just how power works when you're dealing with percentage uncertainties. So 2 times 0.4, which gives you 0.8%. Then you find out percentage uncertainty in T. That would be 0.01 divided by 4.28 into 100%. And no, you don't have to convert these values to centimeter because um, uncertainty is in millimeter and the value is also in millimeter. So uncertainty by value, the units get cancelled out. So if the units are consistent, you don't have to convert. It's 0.23, right? D done, T done, you are left with F. So percentage uncertainty in F would be uncertainty by value, that is 0.2 divided by 11.6 times 100, which gives you 1.72. Since all of these are in product or division form, you just add up all of their percentage uncertainties. So the language you deploy is percentage uncertainty in d squared by 8tf. Oh, one more thing. Constants such as 8 do not affect percentage uncertainty. So you just add up all of these values, 0.8 plus 0.23 plus 1.72, which gives you 2.75, or you can round it off to 2SF. That will give you 2.8%. We are just halfway there. This is, like I said, one of the lengthiest 2-mark questions ever. Then, let's find out the value of d squared by 8tf. D squared by 8tf would be, you take 1 on the other side, that is n minus 1. So the value of n you had previously found out was 1.63 in the previous part of the question, minus 1, which is 0.63. So the value of d squared by 8tf is 0.63. You have uncertainty in d squared by 8tf. You have the value of d squared by 8tf. So recall the equation, percentage uncertainty equals to uncertainty by value. So uncertainty in d squared by 8tf would be equal to percentage uncertainty into value, as in 2.8% times the value is 0.63, and this gives you 0.63 times 2.8%. The value is 0.018. 0.018. But the question asks you to find out the percentage uncertainty in N. So percentage uncertainty in N would be the uncertainty in this entire part. So you have already found out the uncertainty in d squared by 8tf, which is 0.018, and 1, it's a constant. It does not have an uncertainty, right? So uncertainty in d squared by 8tf is 0.018, which is the uncertainty in n, 0.018 divided by, should you remember the value you had found out for n, which was 1.63 times 100%, and this gives you divided by 1.63 times 100. The value is 1.1%, and this is your actual value. I've never seen a lengthier 2-mark question. The next part of the question says, the refractive index of crown glass is 1.52. Deduce whether the lens could be made from crown glass. So this is something along the lines of whether this value is valid, whether this value is acceptable, right? So whenever you come across a question like this, the simplest way and my personal favorite way is comparing the percentage uncertainty with percentage difference. You already have the percentage uncertainty, which is 1.1%. Now, what you're left with is finding out the percentage difference. So percentage difference between this value of refractive index for crown glass and your value of refractive index for whatever material that was, 1.63 minus 1.52 divided by, okay, so a lot of people struggle with what to divide with when it comes to percentage difference. So the way I tell my students to remember it is with, you are trying to find out the percentage difference between this value and your calculated value. So how different your value is from the value given in this part of the question. So you have to find the percentage difference, or how different is your value from this value. So you divide by the reference value, 1.52 times 100%. So this gives you 1.63 minus 1.52 divided by 1.52 times 100. So this value is 7.2%. Now comes the most important bit, that is the conclusion. Always remember, you compare percentage difference with percentage uncertainty. Since percentage difference is greater than percentage uncertainty, which was 1.1, it is not made of crown glass. And say, if the percentage difference was smaller than percentage uncertainty, then it is acceptable, then it is valid, and then you could have said that it is made from crown glass. Thanks for watching.